All right, Algebra 2, how we doing, guys? Hopefully we're doing all right, and you guys are watching the videos, taking notes, all the stuff that I tell you to do in class. I really hope you guys are doing this, all right? It's going to pay off, trust me. Okay, so we are in section 5 today of chapter 5. We're talking about complex numbers and roots. This is welcome to the world of imaginary numbers. All right, so up to this point, we've basically our whole lives dealt with just real numbers. All right, well, now we are getting into what's called imaginary numbers. And I'd like everybody to take a look at page 350. There's a chart there that talks about imaginary numbers. You need to know and understand this information that's in that chart. Also, another one in the middle of page 351 that talks all about complex numbers. You're going to want that chart as well. All right, I promise you guys, this isn't for my good, this is for your good. All right, so let's see what goes on with the rest of this section here. Key terms are going to be important. All right, key terms, the key concepts, but there's 6 key terms here. Look them up, understand them, write them down. You never know when that may come back, and you need to know them. All right, next thing is basically what's the ultimate premise behind using the imaginary numbers is to now deal with negative square roots or negative radicals, okay? And we're going to need to isolate that negative. And so this is where we introduce the lowercase I. So that lowercase I is now going to represent the square root of -1. Okay, and if you copy down that chart, you already have that info down. If you haven't, pause it, take the time to do that. All right, so we're going to try to isolate that negative square root and pull that I, that lowercase I, which is the square root of -1, pull that out of the radical and then take care of everything else. And then right at the end, you still have to incorporate that lowercase I into your answer. All right, the complex number format, make sure that you have the real number, which is just the regular number without the I, that comes first. Then you're going to have a plus or a minus, and then the imaginary number, okay, which you could have basically a coefficient, which is B right there, and then I, which is representing the imaginary number. All right, as it says, pay attention, give your best effort, everything that you have, guys. That's not cheating, that's telling the truth, that's making sure you guys are following everything the right way. All right, so let's go into our example problems here. Okay, step 1, like I said, let's try to isolate and pull out the -1 that we are given. So here we go. First step, we're going to break this down into 2 different parts here. We're going to take out the square root of -1, which would leave the square root of 12 now. Notice a positive 12 there by itself. Then we need to break this down. So this is like factor trees with square roots. And don't forget, those square roots need to stay there until you actually simplify a square root out. Okay, and here's what I mean. We still have a square root. We still have a square root. But the square root of 4 is 2. Now it's okay to not have a radical there because the radical of 4 is 2. Now here's what we're left with. You have 2, radical 3 can't be simplified, and you have square root of -1, which in this case is your lowercase I. So now let's put it all together, and what we're going to be dealing with is, let's use a different color here. You have 2I square root of 3. That would be the simplified solution here that you're looking at. Once you pull out that radical -1, you essentially have now isolated I, and you need to take care of everything else. Okay? All right, let's do another one. All right, first step. Let's pull out radical -1, which basically is I. All right, so pull that out. And now what you're dealing with is just square root of 63, which is now square root of 9 and square root of, let's see, what is that? 7, right? Okay. Now the square root of 9, that can go one step further. That is 3. And now we can't forget. Let's go ahead and underline this guy. You were given a negative 1/3 that was already outside of the square root. Now you'll notice you have a positive 3 that is now outside of the square root. So let's start putting all of this together so you can see how it's going to simplify into our answer. So you're going to have a 3 multiplied by a negative 1/3. There's still an I right there. And then don't forget there is a radical 7 left over. This part right here, 3 times a negative 1/3, that just becomes a negative 1, which multiplied by I would give you a negative I square root of 7. That would be the final solution right there. Okay, so it's important and very, very key to remember you had a negative 1/3 given to you. That needs to be dealt with once you start to simplify that radical. Okay, all right, so let's keep on moving. Now we're going to solve, but in this case, we're not given a negative radical, but we will be creating a negative radical. All right, so here we go. This 25 has to get moved over here. 9x squared now equals a negative 25. You can start to see what's going to happen, hopefully. All right, got to get rid of that 9. Divide both sides by 9. That crosses out. Now we're looking at x squared equaling a negative 25 over 9. And we need to get rid of that square. So we're going to take the square root. Okay, so the square will nullify or take away that 2 right there. So they cross each other out. There's an x just by itself now. But as you can see, we now have a negative 25. We have that 9 right there. And we can simplify this down. But that negative 25, we have to deal with that. We're going to take out an I. All right. So equals, take out an I. And if we take out that I, that's now essentially saying that what we have is the square root of 25 over 9, which we can do because the square root of 25 is 5 and the square root of 9 is 3. But there's one last piece. Whenever you take square roots, you need to remember to put plus or minus in your answer. So we pulled out the I, that took away that negative sign. Then we were just dealing with a radical 25 over 9, which simplifies down to a plus or minus 5 over 3. All right, so this would be the final answer right there for that one. Okay, good. Let's move on. Number 4 here. All right, same thing. We got to take this 48. We got to move it over. So x squared equals now a negative 48. And we got to get rid of that square. So we take the square root. That goes away. That goes away. X is now by itself. That's good. However, we got to get rid of that negative sign. So we're going to pull out I. And now we have left over radical 48. And now we got to break this down into its parts. Let's see. Let's do, we could do 12 and 4. Then 12 would go one step further into 4 and 3. Each of these 4s would become a 2. And then those 2s would need to go together and go back and become a 4. So here's what we're looking at. We've pulled out now a 4. We still have a leftover radical 3. And don't forget we pulled out I right there as well. So now put all of this back together, and we have x equals, don't forget that's actually going to be a plus or minus 4 I radical 3. All right, that's the final answer there for example 4. All right, let's move into a new concept here. All right, example 5, we have to find the values of x and y. You want to see one of these problems already worked out? Go ahead and see example 3, page 351. They already work it out for you. I already started to diagram this, okay? Because you have 2 parts that will be considered real. That's done in red, the 2x and the -8. You also now have 2 parts that are considered imaginary. That's the -6i, that's the 20y connected with I. Anything connected to I is imaginary. If it doesn't have I, it's real. All right? So now pull those pieces out, separate them, and then it becomes very easy. All right? So let's separate 2x equals -8. Simple enough here. X is going to be -4. Boom, that was easy. Once you separate it, now over here, don't include I when you pull them out. We know they're imaginary because they were given I. But now all you're including is just -6 equals 20y. Y equals a -3 over 10. All right, that was basically me already just reducing the fraction. You're going to get a -6 over 20, reduce -6 over 20, and it becomes -3 over 10. All right, but the most important thing is knowing pull out the real, solve for x. Pull out the imaginary, solve for y. Okay? All right, and we have example problem 6. Stay with me. Keep working, keep working. All right? Here we go. So we're going to use completing the square. So you can see this is not a perfect square trinomial. So we're going to have to take that 13, put it over to the other side totally by itself, and solve for a brand new c value. Remember completing the square. All right, x squared plus 4x plus, we're going to create a brand new c value, equals a -13. Remember, I moved the 13 over, and then we're going to have to say plus, and we're still going to have a new c value. How do you solve for c? Don't forget, c equals b divided by 2. Take that, square it. So that's going to give you 4. 4 divided by 2 is 2. Square it, it's 4. So that's what we're plugging into each of these values. The blanks are now our new c values. All right? Okay. Now, this right here, this is a perfect square trinomial. This is going to factor perfectly into x plus 2. This over here is now going to become a -9. All right? Now you're going to start to see, okay, we have a negative somewhere. I'm going to be taking a square root and pulling out an I. All right? So let's get rid of the square. So that's going to go away because of that, leaving us with x plus 2 equals, and the square root of -9, pull out the negative, that is I, and then 3, there's going to be a plus or minus. Now we're not done because we need to get rid of this guy right here. Need to move that 2 over. So you're going to be left with x equals -2 plus or minus 3i. All right, -2 plus or minus 3i. And one thing I want you to notice is the format. Notice how this format, I have the real number in front, I have the imaginary number in the back. And that's exactly what we're supposed to do right there. That's the complex number format. Always stick to that format. Real in front, imaginary in the back. Okay, let's scroll back down. There we go. Final example problems, very easy. There's the format, don't forget it. A plus BI. Complex conjugate. It's a big old fancy phrase here. It really just means do the opposite. Do the opposite. This is how simple it is to get our answers. All right, so what you're given is 9 minus I. It's already in the right format. You have real, then you have imaginary. What's the opposite? 9 plus I. Boom. That one's done. We love these problems. Now, B, there is no real number given, so you don't even need to worry about. What's the opposite of a negative 8I? A positive 8I. Boom. That is it. All right, end on the simple stuff. That's good. All right, that covers us. That's section 5 of chapter 5. You got complex and you have imaginary numbers. All right, see you guys in the next one.